Welcome to the Clinical Ranking and Evidence Dossier on dietary supplements targeting cellular senescence. We'll be distilling data on the top 10 geroprotectors, focusing on efficacy, mechanism, and clinical data from 2020 to 2025. Quercetin leads the ranking, backed by human randomized controlled trial evidence. Fisetin is the challenger, showing potent senolytic activity in animal models with human trials pending. Curcumin and resveratrol are considered the bottleneck due to critical evidence gaps and poor bioavailability. Geroprotectors target senescence using two primary mechanisms. Senolytics, or the assassins, induce selective apoptosis to clear senescent cells, like quercetin and fisetin. Xenomorphics, or the diplomats, suppress inflammatory pathways while leaving the cell intact. Agents include resveratrol and NMN. Our 100-point evaluation framework prioritizes evidence quality at 40%, strictly favoring human RCTs. Effect size accounts for 30%, measuring the magnitude of marker reduction. Marker specificity is 20%, requiring direct reduction in senescence markers. Finally, safety accounts for 10% of the score. The Geroprotector leaderboard is tiered. Quercetin is the clinical leader. Tier 2 compounds, including fisetin and resveratrol, have robust preclinical data. Tier 3 includes compounds like apigenin and NMN with strong cellular mechanisms. Tier 4 represents compounds with experimental and modest effects. The biomarker matrix highlights the effects of each compound on key senescence markers. Fisetin shows reductions across all major markers. Quercetin lowers SASP clinically, but lacks in vivo P16 data. Many popular compounds exhibit gaps in direct biomarker measurement. Quercetin, scoring 91/100ths, is the clinical leader, showing both senolytic and xenomorphic mechanisms. A human RCT found that it reduced senescence and inflammation in men undergoing cardiac surgery, but the benefit was sex-specific, yielding no benefit in women. Fisetin scores 85/100ths, based on robust animal and cellular data. It's a highly potent senolytic, clearing senescent cells in vitro, and extending lifespan in mice. The crucial limitation is the lack of published human RCTs, though trials are currently ongoing. Resveratrol and EGCG are popular polyphenols. Resveratrol is a xenomorphic SIRT1 activator, and EGCG is an antioxidant. Both are limited by poor bioavailability and a lack of significant, targeted human senescence data. High doses can also cause GI distress or hepatotoxicity. Targeted xenomorphics include apigenin and NMN, both scoring 61/100ths. Apigenin is a powerful SASP inhibitor, but evidence is strictly in vitro. NMN is an NAD+ precursor that attenuates vascular senescence, but it currently lacks clinical trials measuring direct senescence endpoints in humans. The experimental tier, with scores 45 to 50, includes piperlongumine, a research chemical with no human data. Curcumin is hindered by terrible bioavailability. Vitamin E is a broad antioxidant, and olive polyphenols show promising cellular data, but lack in vivo confirmation. The clinical reality reveals systemic evidence gaps. The in vivo bottleneck means most data is from cell cultures or animal models. The absorption flaw refers to poor human bioavailability of many compounds. Furthermore, many studies rely on isolated biomarker proxies, and long-term safety is unknown. In summary, quercetin is the clear choice with RCT evidence, though efficacy may be sex-specific. Fisetin is on the watch list as the preeminent senolytic candidate. Dietary synergy, through foods rich in polyphenols, offers baseline benefits safely. Always consult a healthcare provider before starting any targeted high-dose geroprotective interventions.